Hi guys, welcome back. You can see in front of you my bandspread meter. If you can see on the bandspread meter, the meter is deflected. If I touch that one side, he will dip. So I checked that already. But what I wanted to show you is my frequency meter is tuned at 3.45 megahertz. So what I wanted to show you, and that's very exciting actually, and that's you see when that meter is on frequency, you see him dip. And notice you don't see any reaction from that meter, but as soon as I touch this here, then you see him move, and that's the dipping of that meter. So if you draw energy from the dipper, then you can see it on this meter, and the other meter you can see which frequency you're on. How I know that? Because I put that on 56 on this scale. According to my paper, this paper here, upside down, I have here 56 and on 3473 kilohertz. So that's actually the 80 meter band. So that's exactly right. Okay, so that's very chuffy. The only thing I want to report is that tuning capacitor is not a butterfly capacitor. It should be a butterfly capacitor. And as you can see, if I touch this, you can slightly see it. You have a hand sensitivity. So that's because that is not the capacitor what should be in there. So you can see that it works, and the intention behind it is that we can analog measure frequency, analog we can make it in a band spread, and analog we can see if the LC combination is resonating on that frequency. That's the only thing, and apart from that fact, we have also a capacitor meter on top of that. So the only thing what I have to say now is what I have to do. I have to connect 2 R's of the capacitor meter. So I have to push that switch over. It goes to the capacitor meter. Then the redipper will filaments will extinguish, so go out, and the filaments of the double triode will light up, and the other part will burn. So I have to report it is an enormous success. The only thing I have to do now is to get that capacitor meter going. The other thing I have to report to you, both grounds from the capacitor meter and the redipper are isolated from this. So this part is completely standing on its own, and you can with the capacitor meter, if you connect that up, you put your capacitor, tuning capacitor here, put your capacitor meter, you can actually see which capacitor you are on. If you put your tuning capacitor on those two, you can see what the range of the tuning capacitor is, maximum and minimum. So that's is actually on a video on its own, isn't it? So I put that on my power supply. I will go up to my power supply so you can see that. So I didn't use the power supply from what I put in there, but the transformer. The only power that it provides is the filament. The other one I took the fuse aside and took the valve out, and I connected it up that way, so I have some control over the current as it is taken off. So I will go to my meter. Let's have a look. I have to zoom in a bit. And they go a bit closer now. And that's the reflection of the back here. Now that's what you see. I can't help that, you guys. So I'm sorry about that. That's the reflection on that side I have. So there we go. You can see on the right hand side, you see the voltage is on there. It's 300 volts, and it takes about up 8 milliamps. You can see that. So that's the way how you control making meters or what apparatus you want to construct. You have control over your voltage, and you have control over your milliamps. So what that thing is taking. So I will switch now off. You can see the voltage going down, and also yeah, you see him going. I'll leave it go until go down. I switch off the frequency meter as well. So this is going down as well. So I have to tell you a bit more. So I will put the camera back in again. There we go. I'll go back again. And I have to show you something. We'll focus. I go a bit closer. And focus again. Okay, you see that yellow wire? I'll take my pencil. You see that yellow wire here? That one on the BNC. This goes straight on to the anode of the grid dipper. I'll switch that over as well. Okay. And take that out of the socket. You won't believe it, but twice or 3 times over I had a shock. You get a walloping and you see nobody. That is disgusting. Anyway guys, so this is actually connected to the BNC, and that BNC is, and I'll zoom out again. I'm difficult. And we'll focus again. That cable here, the BNC cable, is that one here, is connected up to the front here on top there, and that's a 5 picofarad connection. So I have the high voltage straight on to the BNC, so I have to put a sticker on the back that as a sort of a warning that you have to don't poke in there with some implement so you get a horrible shock for 300 volts or something like that. Okay, yeah guys, that is what I have to report, and I think I enjoyed it quite a bit, you know, because it's a very great success anyway. So the next thing we're going to do now is get the meter completely done. So this is part 2, and part 3 I will go through with you all with what you see on the bench. We go and make a span spread from top to bottom. We're going to check the capacitor. We're going to check out what the maximum capacity and the minimum capacitors you need for a certain frequency, resonance frequency, and then we can adjust our meter, frequency meter onto with the scale on the frequency we want. Then we put a grid dipper on and we tune him that this meter is dipping. From that on we can connect, have a look, our stuff is connected up to there. We can tune then up the tuning capacitor if we can connect them up here. Our tuning capacitor, and then we can see the frequency what we put in here. We can see on this meter here, this one, if he's on resonance or not. And you have to do that twice. The lowest frequency, this is 3.5 for instance, and the highest frequency is 3.8. You will have to adjust this knob, this scale, and then you automatically you tune your frequency meter or your dipper onto the frequency, and then you can see with your tuning capacitor if the meter dips, if that is in resonance. And that's the whole shebang. That's all there is to it. So it's a very nice story. Well, I conclude this video with part 2, and then we'll see you on part 3. Alright?